All right, so let's look at how we go about getting a exponential regression and why we would choose a exponential regression. One thing I do want to show you on the ti-nspire, say you want to see where this data came from, hit your control and your up arrow on your D-pad, and that'll bring you to all the screens that you have open. And from there, you can go and choose any of these open screens. I think it's this one. It's hard to see. Yeah, there we go. So here's a set of data that I put in regarding the number of bounces a tennis ball makes and the height at which it peaks before it goes back down again. So each bounce, I measured the height and recorded it in this chart. So, and of course, we don't know what that data looks like. So let's go ahead and take a look at how that's in the scatter plot. So let's go ahead and put the number of bounces as our independent variable. And over here, we want the height that resulted from it. That's our dependent variable. And there we go. Now, as you can see, this kind of has got a small sloping curve. So we know that it might not be linear. Also, we know that a bounce can never go negative, so this is just going to get smaller and smaller down here. So when you look at data like that, and with a little practice, you clearly say exponential pattern. So, and it basically is resembling growth and decay, this one being a decay, because the height gets smaller and smaller and smaller. So I'm going to go with a exponential regression. So go down to Analyze, hit your menu, go down to Analyze, and select Regression. And since you said exponential, show exponential regression. So there's your line. It's a nice smooth curve. Here's your equation. Remember, exponential equations have a starting point, and then they multiply the ratio. It's a common ratio times the number of bounces. So we're going to multiply that. That's why it's exponential, because the variable is in the exponent. So it looks like the tennis ball started at a height of 3, and the bounce percentage, the rebound percentage, is about 55% or 0.55. So there's your equation, and there's your regression model for exponential equations on the ti-nspire. I hope that helps, and thanks for watching.